Hold up your hand. Every atom in it, the iron carrying oxygen through your blood, the calcium in your bones, the carbon holding your DNA together, was not made on Earth. It was not made by the sun. It was forged inside a star that lived, died, and exploded before our sun ever existed. You are not simply made from stardust the way that phrase gets used casually. You are made from the wreckage of at least one star's death, probably several scattered across the galaxy and pulled back together by gravity and chance into you. This is not poetry. It's physics, and scientists can trace the exact process, element by element. Most people have heard some version of "we are made of stardust" and assumed it was just a nice way of saying we come from nature, that everything is connected. That undersells what actually happened. For most of the 20th century, physicists didn't actually know where most of the elements in your body came from. Hydrogen, the simplest element, was easy. It formed in the first few minutes after the Big Bang. But carbon, oxygen, iron, calcium, the heavy elements that make up you? Nobody could fully explain how those got made or how they ended up here on a rocky planet, arranged into something that could ask the question. The sun and Earth formed together, from the same swirling cloud of gas and dust, about 4.6 billion years ago. Whatever heavy elements were in that cloud had to come from somewhere before the sun even lit up. Which means, before you can explain a single atom of the iron in your blood, you first have to explain a death that happened long before our solar system was born. In 1957, for scientists Margaret Burbidge, Jeffrey Burbidge, William Fowler, and Fred Hoyle, published a paper that would become one of the most cited in the history of physics. It's known simply by their initials, B²FH. They worked out, step by step, how stars build heavier elements out of lighter ones, crushing hydrogen into helium, helium into carbon, carbon into oxygen, all the way up the periodic table, using the star's own gravity as a furnace. But there was a gap in the math. Fred Hoyle noticed that carbon, the element every living thing on Earth is built from, shouldn't be able to form in the amounts we actually see. The known nuclear reactions were too inefficient. So Hoyle predicted that carbon nuclei must have a very specific, previously unknown energy state that would make the reaction far more likely. He predicted it on paper from pure theoretical necessity before anyone had detected it. Physicists went looking. They found exactly the energy state Hoyle predicted, now called the Hoyle state. Without it, stars could barely make carbon at all, and without carbon, there is no you. The reaction is called the triple alpha process. 3 helium nuclei fusing together inside a dying star to make 1 carbon nucleus. Every carbon atom in your body passed through that furnace. But here is where it gets stranger. Carbon and oxygen, B²FH could explain. Iron mostly, but some of the heaviest elements in your body, things like strontium, gold, platinum, needed something far more violent than an ordinary dying star. For decades, nobody had directly observed the event that could make them. Then, in August 2017, gravitational wave detectors picked up a signal from 2 neutron stars, the ultradense collapsed cores of 2 dead stars, colliding and merging 130 million light-years away. It was named GW170817, and for the first time, telescopes all over the world turned to the same patch of sky and watched the aftermath in visible light. In 2019, a team led by Dirac Watson published a study in the journal Nature, analyzing the light from that collision. They identified the signature of strontium, a heavy element, being forged in real time in the debris. It was the first direct observational proof of a process theorists had only modeled on paper, that the heaviest elements on the periodic table are built in the extreme seconds after 2 dead stars smash into each other. That collision blasted newly forged heavy elements outward across the galaxy, the same way earlier supernovae had scattered carbon and oxygen and iron. Simulations by researchers including Daniel Engels-Alcazar at Northwestern University suggest that a significant fraction of the heavy elements in a galaxy like ours didn't even stay near the star that made them. They were flung across enormous distances, drifting between galaxies before ever settling into a new cloud of gas. Somewhere in that scattering, the atoms that would eventually become you were set loose. This is not ancient history happening somewhere else. It's sitting inside you right now. About 65% of your body by mass is oxygen forged inside dying stars. Roughly 18% is carbon, the exact product of Hoyle's triple alpha process. About 10% is hydrogen, left over from the Big Bang itself, the one ingredient that didn't need a star at all. A few percent is nitrogen. And scattered through all of it, in your blood, your bones, your teeth, are trace amounts of elements that could only have been made in the most violent event physicists have ever directly observed. Two dead stars colliding. You didn't need to go looking for this. It's not a metaphor you chose. It's the literal, physical inventory of the atoms your body is built from, and every one of them has a birth certificate written in a star that no longer exists. If the idea that you're standing on the wreckage of dead stars is the kind of thing you want more of, subscribe. This channel exists for exactly this feeling. Then keep going, because it gets stranger still. Somewhere out there, some of the atoms that make up you right now will eventually scatter again and become part of something else entirely. You are not the end point. You're a stop along the way. And here is the part that is hard to hold on to. None of the atoms in you were made for you. The star that fused the carbon in your bones didn't know you would exist. It didn't know Earth would exist. It burned through its fuel, ran out, and either puffed off its outer layers as a planetary nebula or detonated as a supernova. An explosion so bright it can, for a few weeks, outshine its entire home galaxy, because that is simply what happens to a star of a certain size when it dies. The elements didn't travel toward you. They scattered in every direction, obeying nothing but gravity and momentum, for hundreds of millions or billions of years, through empty space, through the wreckage of other stars, through clouds of gas being pulled together and torn apart again, until, by pure physical consequence, some of them ended up in the gas cloud that became the sun and the earth. And from there, through geology, through chemistry, through billions of years of evolution, into you. You are not stardust in the gentle, symbolic sense people usually mean. You are the literal, physical aftermath of stars that died so long ago their light stopped reaching Earth before our solar system was even a cloud of gas. The explosion is over. The wreckage is reading this sentence. So what does that make you? Physics can tell you exactly which elements are in your body and, for most of them, precisely which kind of dying star made each one. It can trace the whole chain from the Big Bang's hydrogen to a supernova's iron, to the collision of two neutron stars that forged the strontium in your bones. What it cannot tell you is why any of those atoms arranged themselves into something that could ask the question. Somewhere between a dying star and a reader holding these words, matter woke up. You carry the wreckage of stars that died before Earth existed, and somehow, in you, that wreckage sat up, looked around, and started wondering how it got here. If you want to know exactly how unlikely it was for any of this to happen at all, there's a video on this channel about why the universe should not exist. The odds were close enough that we almost weren't here to ask. Watch that next and subscribe, because the human story is stranger than you were ever told.